Good morning, students. Uh, Today I am going to discuss about the oxygen mass transfer in bioreactors and KLA determination. In a bioreactor, we need oxygen, right? In the bioreactor, we have a medium and the fermentation is going on. For the organism is introduced, inoculated into the fermentation, the organism needs some oxygen. So how the oxygen is entering to the fermentation? What are the mass transfer occurs while during the fermentation? So that is to be going to be studied in this topic, that is in the oxygen mass transfer in bioreactors, and how to determine the liquid phase mass transfer coefficient, that is the overall liquid phase mass transfer coefficient, how we can determine, that is the KLA determination. What are the methods are used to determine the KLA, and how the mass transfer occurs in a bioreactor while the inlet of oxygen introduced into the fermentation, means how the mass transfer occurs. Okay, we are going to see in the detailed manner in this class. So the first one is the you see here in the PPT slide we have a picture. So how the particular oxygen is introduced into the system. You see, in the fermentation we have a medium and the inoculated organism. So the organism utilizes the medium content and grows the particular whatever the content will be present in the medium, it will utilizes it and it will grows. Okay, the organism grows. So while growing, it needs some oxygen. Okay, but you see in the broth contains how the broth will looks like. It will looks like a liquid form, right? The broth not only in a liquid form, it will have some cells also, because we have inoculated the organism, so the organisms get doubles while increasing a time, it get doubles. So the particular liquid contains here inoculated that is the cells, and also the broth. So that the combined one is we called as a broth. So broth contains what? Liquid and the cells. So from into the broth, how the oxygen, while we introduce the oxygen into the fermentation system, how the oxygen enters into the particular cells. Okay, because the cells needs the oxygen, how the oxygen enters into the cells, that is will be clearly depicted in that picture. You see this picture will closely you will analyze how the oxygen is enters into the system. Okay, so in this picture the first one is the gas bubble. What? Because the oxygen is introduced into the form of a air. Okay, air is a form of a gas. So in the gas bubble, how it will be enters into the individual cell. The first one, the gas bubbles enters into the gas liquid interface, diffused into the gas liquid interface, and from the gas liquid interface it will diffuses through the liquid, because the broth contains a liquid. So the liquid surrounds is the liquid film. So the gas here is oxygen. Okay, keep in mind the gas here is oxygen. So the oxygen is diffused through the gas liquid interface, and it will diffuse into the liquid medium. Okay, liquid film. So from the liquid film it will be transported into the two-way. One is a cell clump. So cell clump means the so many cells are clumped together in the particular, because in the broth you don't see some cells are in a single cell. Okay, some cells are in clumps together. So in the cell clump, how the oxygen is enters into the cell, that's the one way of transport. Another one is some individual cells also present in your liquid broth, right? So how this in the individual cells, how the gases enters into the particular cell. So there are two transport. One is individual cell, another one is cell clump. So from the liquid, from the diffused from the liquid film, it will enters into the film interface. Okay, when you have an individual cell, means it will surrounds us a liquid film. This liquid film is nothing but what? Liquid broth. Okay, so from the liquid broth it will diffuses through the liquid film and introduced into the individual cell. So the cell, that the main inside your cell only the site of oxygen reaction will occur, and the metabolisms are all occurs within the cell only. So our oxygen will go into the cell, but pass on into main hydrants, that is liquid. If it will first diffuses through from the gas bubble, then liquid film, then it will be transported into the liquid film, surrounds this individual cells. Individual cells surrounds this liquid film, it will be transposed to the liquid film and then to the inside of the particular individual cell. There the oxygen, there is a site of the oxygen reaction, that will be the oxygen will be occur, and the oxygen will be oxygen will be taken out from the cells and it will go, right. The second transport is cell clump. Here the cell clump means the so many cells are clumped together in a particular broth. So how the gas is entered into the cell clump means, first it will diffuses through the liquid film surrounds the cell clump. Now first it will diffuses through the liquid film and then into the cell clump. Within the cell clump only there will be a individual cell, so it will diffuses through the cell clump and then to the individual cell. So in between the liquid film and the individual cell, there will be a liquid solid interfaces present, because the cell clump outside of your cell clump is having a liquid solid interface. So there will be a two types of liquid solid interface will be present. So the diffusion of the particular gas is introduced into the liquid film and it will diffuses through the liquid solid interface, and then further it will diffuses to the individual cell. Okay, when the individual, that is a single cell, means it will be directly diffuses to the liquid film and then enters into the individual cell. But in the case of a cell clump means it will first enters into the liquid film and then it will cross on to the liquid solid interface and then it will be move on to the individual cell. So in the individual cell, within the individual cell only the oxygen is required. There is the site of the oxygen reaction will be taken place. So this is a whole oxygen mass transfer occurs in our bioreactors. Okay, so how the oxygen is introduced into the reactor. When the culture of the microorganism needs some oxygen, so from the oxygen it's how it is introduced. Okay, so the oxygen is introduced into the fermentation, but the fermentation having a liquid broth. The liquid broth contains a more number of individual cells and also a cell clumps. Now the cells needs your oxygen, so we have to inlet adding oxygen into the fermenter, and it will cross on how the mass transfer occurs into the fermentation. This picture is clearly depict how the mass transfer occurs in your bioreactor while giving some oxygen into the system. So the next one is at steady state, there will be no accumulation of oxygen at any location in the fermentation, right? The expression here is the rate of oxygen transfer from the bubbles must be equal to the rate of oxygen consumption by the cells. Okay, how many amount of oxygen consumed by the cells, that's to be equal to the how much amount of oxygen transferred from the vessels. Okay, so here the oxygen transfer from the bubble is KLA CAL star minus CAL, that is equal to Q naught X. Q naught X is the oxygen consumption by the cells, that is oxygen uptake of your cells. The KLA is the that is the liquid overall liquid mass transfer coefficient. CAL is the concentration of A in the liquid. Okay, concentration of A in the liquid, that is the liquid solubility, mass solubility of the particular system, and then CAL is the concentration of liquid in A. So the expression is nothing but what? How much amount of oxygen consumption, how much amount of oxygen uptake by the cells, that is equal to the oxygen transfer from the bubbles. Then here from that we have KLA is used mainly to characterizes the oxygen mass transfer capability of the fermenter. In the particular system, if the KLA is small, means the ability of the reactor to deliver the oxygen to the cell is limited. Okay, if the KLA is very small, means delivery of oxygen to the particular cell is very limited. Okay, so that's a main point here. And the another one is we can predict the response of the fermenter to changes in the mass transfer operating conditions. Okay, we can predict the fermenter response. While we have to change the mass transfer operating conditions, we can easily predict the response of the fermenter. So how we can change this means in the by using a stirrer. Like that we have to change the mass transfer condition, and the response of the fermenter can be easily predicted. And then similarly, if the rate of oxygen consumption by the cells is accelerates while KLa is unaffected, so here the CLA must decrease. So the expression is X max is equal to KLa CAL star divided by Q naught. That is here the maximum cell concentration. Okay, so that's the expression here. In that KLa must be improved. Here you see that it is generally undesirable for the cell density to be limited by the rate of mass transfer. This KLa critical is equal to Q naught X by CAL minus C critical. This expression is mainly you can easily understand by seeing this graph. You see. So how C critical in the sense the particular cells needs your oxygen, but it doesn't have a oxygen. Okay, so that the condition names is C critical. Okay, critical rate of the cells. If you gives the oxygen means now the cells are get a oxygen and then grow. Okay, then how to deliver the oxygen to the cell? The next topic is delivering the oxygen to the cell. So with this we have studied how the oxygen mass transfer occurs in our the bioreactor. What are the phases, how it get transfers from the gas bubble to the particular individual cell, and also to the cell clump, how the mass transfers occurs through this, and also some expressions also we studied how it will related to the oxygen consumption, and also the oxygen transfers from the bubbles, how it get related, and in what way that KLa must be improved. Like that we have seen till now. Then next one is how the delivery of oxygen occurs to the cells. Okay, in cell culture the oxygen is a key substrate for your growth, production, maintenance activity, right? For all human beings or all the things, the oxygen is the most important one, right? We need oxygen, right? For that for the key substrate, this oxygen is the main substrate for the growth, production, and the maintenance activities. So cells obtain their oxygen in free and non-compound forms called a dissolved oxygen. Okay, cells how can obtain their oxygen in a free form and also in the form of dissolved oxygen. So one of the most important function of the bioreactor is to provide a dissolved oxygen to the cells continuously through a process called aeration. Aeration means you have to give a oxygen continuously through the cells. Okay, well, that is the important function of the bioreactor. So aeration in the bioreactor typically occurs when the oxygen diffuses through the overlay to the cell culture medium interface. Cell culture medium interface means the fermentation, you know the medium is present within the fermentation. When the inoculated culture, the cells get grows. So the oxygen diffuses through the overlay of the cell culture medium interface. Another way how the oxygen is introduced means through means of sponge. Okay, through sponges it will dissolve in the cell culture with the help of agitation. Easily the cells can take in the particular oxygen, okay, from the sponge. So first one is the sponge one, then once it will easily diffuse through the cell culture medium interface. So the agitation will disperses the oxygen bubbles and promotes the mass transfer of the gas bubbles through the interface. How the particular oxygen is entering into the gas liquid interface means because of agitation. It will disperse some oxygen bubbles. Okay, when from the sponges the oxygen will enter. When the oxygen is entered into the fermenter, the agitation will occur. So in that agitation, what happens, the oxygen bubbles get split out from the agitation and promotes the mass transfer of the gas bubbles through the interface. So the rate of oxygen transfer from the gas to the liquid interface is the function of the physicochemical properties of the culture medium. Okay. The rate of oxygen transfer from the gas to the liquid, it's a function of the properties of the cell culture medium. And then not only the physicochemical properties, the geochemical parameters of the bioreactors and the presence of the cells. Okay, all it will depends. The rate of oxygen transfers is depends on the physicochemical properties of the cell culture medium, geochemical properties of parameters of the bioreactor, and the presence of the cell. So the oxygen utilization rate is often a cell line dependent. Okay, how much amount of oxygen is utilized, it's mainly depends upon your cells. So how the cells only determines how much oxygen we need, like that. The next one is that due to its low solubility in liquid phase and increasing metabolic consumption by the cells with time, oxygen is applied continuously to the cells. Okay, if the cells needs a more amount of oxygen, why the cells needs more amount of oxygen means for growing of your cells, and also the metabolic consumption, increasing metabolic consumption of your cells also, that needs more oxygen. So it depends upon their requirements, the cell requirements, the oxygen will be needed. So at that time the oxygen will be given continuously to the cell culture. So the oxygen supply is carefully controlled for the optimal cell growth by manipulating the bioreactor parameters. How we need the cells need more oxygen or a less oxygen, like that the parameters to be easily controlled in the bioreactor. During batch culture, you see there is a different phases in a batch culture. What are the phases? Lag phase, log or exponential phase. Okay. Next one, acceleration phase, stationary phase, and the last one is death or decline phase. So initially in the lag phase, it is the what? That is the here the cells is not growing. First it will be cell accommodate to that particular system. Okay, whatever the medium is present in the medium, like that it will accommodate to the particular system. So that is the lag phase. Here the cells is a self-synthesizing phase. In that the cell density will not improve, right? Only the cells will, okay, it will be accommodated with the particular environment. So this is the first lag phase. During this phase the cells doesn't need some more oxygen, right? In the exponential phase the cells are now grows. So more amount of cells are grows into the reactor. So the cells needs a more amount of oxygen. So here the oxygen utilization rate is automatically it get increased. So here from in that exponential phase only we have determined the mass transfer of oxygen in the bulk liquid. Then okay, these are the oxygen mass transfer in bioreactors. What are we see in the oxygen mass transfer in bioreactors? If we have a fermentation medium means definitely we have a medium and the liquid, that is inoculation culture. We have to introduce the inoculated culture in the medium. Now the cells utilizes the content, that is medium content, and then grows in the fermenter. While growing, the cells need some oxygen. So we have to give in oxygen into the fermenter by means of direct ways or aeration, or by using a sparger. Okay, by using a sparger, the particular oxygen enters into the system. Right. So then some expressions also we studied. Okay, what are the expressions? That is the rate of oxygen consumption by the cells, that is equal to the how much amount of oxygen transferred into the cells. These are some of the expressions we studied. The next one is what? Then agitation. So agitation will improves the oxygen enters into the from the gas bubbles to the gas solid interface, like that we studied. And what are the oxygen utilization rate and the oxygen transfer